Saxon Calculus Lesson 38 is about the equation of the tangent line and then higher order derivatives. So we know that when we're talking about the tangent line, we are getting our slope to basically be 0. Now here's what's going to happen with example 1. Y equals x squared minus 4x plus 3. And then it says compute, and this is a new looking thing. Dy over dx, and then this line, which is basically just doesn't have a little name, it's telling you that you are going to plug in a 3 after you have done the derivative. Unique little thing there. So what is the derivative of this equation? So that drops 2x to the first power minus 4, because the 1 multiplies with negative 4, and then 1 minus 1 is 0, so it drops off. And we already know that this one drops completely off, and so there's nothing with the constant. And now we are told to plug in 3. So 2 times 3 minus 4 is 6 minus 4. The answer is 2. So that's what's happening when we're doing these equations and we have this lovely new format. Example 2, find the equation of the line tangent to the graph of y equals x squared minus 4x plus 3, it's the same thing, when we have x equals 3. So we are going to find the this one, same equation, and we know what we got when we plugged in here with the 3, so it looks super similar, but this one says we're not finding the derivative and plugging in 3, we're finding the equation of the line that is tangent to this. So if I'm picturing a graph with a squared and a y, I know it's a parabola of some sort, and I'm looking for a line that is tangent to it. So hitting it in one spot, basically, and that spot is supposed to be where the x is 3. That's what that's basically saying. And because the slope is 0, my dot should actually be here on the line because it's 3, 0 implied here at that tangent spot. So the equation for that line should be in the format of y equals mx plus b. We do not necessarily know at this moment where we cross the y line, so I can't shortcut with that. Hang on one second. I was debating what was the best way to deal with this, and I think I am going to follow what the book was suggesting. So because I know that I'm creating this tangent spot, which gives me the 0.30, if I plug that in here, so the 0 is the y, 3 is for the x, 3 squared is 9, minus 12 plus 3, that proves that we do get the 0 there. And when we did the derivative, we got 2. So 2 was my slope because the derivative provides me slope. So if I then fill in 2x plus the b, I think this actually, okay, so this proves 0 equals 0, but if I plug it in here, 0 and then 3, there we go. Now I can get my b. So this is 6. b will equal negative 6. My equation is y equals 2x minus 6. All right, so now that we've gotten there, let me recap that just to make sure that that made sense. So if I do the derivative of this formula, I will get the slope. I can fill that into the y equals mx plus b. I then know that if they told me x was the 3, that I'm hitting that spot, that's where the tangent should be, that gives me the 0.30, which I use into the y equals mx plus b to get b. Hopefully that is a little clearer. Now, example 3. Find the equation of the line that is tangent to, that sounds similar to the last one, y equals e to the x when x is 0.8. So since we know we want the equation of the line, we know it's y equals mx plus b. And we know that if we derive this, we get that same e to the x. And if I plug in the 0.8, e to the 0.8, that will give me the slope part, and so that decimal is 2.23. And then I know that my x was 0.8, so multiply by 0.8 there, and that gave me the 0 for the y, and then I can solve for the b. Oh, hold that thought. Just a second. Why are they not using your 0 here? All right, my issue is in the way I read the problem. So I flipped it in my brain and I made the assumption, which I should not have done, that they were saying when I plugged in the 0.8, I got 0. But when I look here at this equation, I realize that's not true, because when I plug in 0.8 for this x, y is the same answer as I got for the derivative and plugging it in. So this, to be accurate, should be 2.28 equal 2.23 times the 0.8 plus b. So because the derivative is the same with e to the x, and I need to test it plugging in the 0.8 to this equation to get this y value, that is more accurate. So then, let's see, the b comes out 0.45, and you just need to do that on your calculator to prove to yourself that that works. Now the final answer would go back to y equals 2.23x plus the 0.45. Okay. Example 4. Find the equation of the line tangent to f of x equals sine of x when x equals 1. And they remind us that when we do these formulas, they should be in radian. Now, we are going to find our y value, or our f of x here, by plugging in the 1. So what is the sine of 1 on the calculator? Well, that's 0.84. So f of x here will equal 0.84. So that's going to be the y value in my equation. Then I need to do the derivative to get the slope. We're going to multiply it by the x that is 1 and solve for the b. So the derivative of sine, we know, goes to cosine. So then we find on our calculator the cosine of 1, and that is 0.54. So that is our slope. 0.54 can plug in for the slope. Multiply by 1 doesn't change it. Subtract 0.54 from 0.84, and that gives you 0.3 is the b. And now we fill into the full answer. Y equals 0.54x plus 0.3. Now, technically, each of those have 0 point in front of them. Again, that's one of those shortcut things that I rarely write because I try to be very precise that I can tell that that's a decimal point, but to be accurate, it really should say 0.54 and 0.3. Part B is higher order derivatives. Now this means we're basically deriving more than one time. So we know that when we see f and our lovely symbol and then x, we're being asked to derive it one time, or we see it as dy over dx. If they want me to derive it 2 times, they're going to give me 2 tick marks, or they're going to say d squared y over dx squared. That's telling me do it twice. If they want me to do it 3 times, on the F one, it's exactly as you would expect, and on this one, it is now what you would expect, d3 over the dx cubed. Those are asking us to do it 3 times. Now, example 5. They give us y equals 3u to the 5th, and they say find d2y over du squared with our line and then plug in a2. So we are only, thankfully, supposed to derive twice here. So let's do that. 5 times 3 is 15 u to the 4th. That's deriving it one time. Now do it again. 4 times 15 gives you 60 u to the 3rd. Now that's derived twice. And then we are told to plug in a 2. So 2 cubed is 8. 8 times 60 is 480. Example 6. Find f of x equals 1 over x squared, and then they tell us do it 3 times and plug in a 2. So this is a much shorter way of telling me the same thing that this was in plugging in the 2. That's just a cleaner format, but you need to recognize all of them. So before I derive it, I need to fix this x squared and make it, moving it to the top, makes it negative 2. So I'm actually deriving x to the negative 2nd. So that the first time I derive makes it negative 2, x to the negative 3, because I subtract 1. Second time I derive, I multiply and get 6, x to the negative 4. Third time I derive, I get negative 4 times 6 is 24, x to the negative 5th. And then I plug in the 2. So negative 24, 2 to the negative 5th. Now, that can turn into the fraction 1 over 2 to take it to the 5th power, so it's no longer negative. So I'm going to leave that negative 24 in the numerator, and I'm going to make it 2 to the 5th down here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So negative 24 over 32, and that does reduce to negative 3/4 by taking 8 into those.